Okay, to understand more our work and energy principle, let's apply it here in our sample problem number 2. So we have a given automobile here that is a weighing 3,500 pounds. Take note, this is in imperial or English units, not an SI unit. And then traveling along a 10-degree incline road with a speed of, so at point A, we have a speed of 20 foot per second. If the driver jams on the brakes, causing the wheels to lock, determine how far S. So ato na siyang isolve, no? Pagkataon to the distance S. The tires skid on the road. The coefficient of kinetic friction between the wheels and the road is mu k equals 0.5. So say bato na to ani. So in solving problems, di ba? Itong first ginabuhat is we write the givens. So for example, problem number 2, this in imperial units. Therefore, dili joules ato ang unit for energy and work, that is foot-pound for the imperial units. So ang given na to, we list down here. We have the weight that is equal to 3,500 pounds. And then what else? The road is inclined at 10 degrees plus our initial velocity at velocity at A, that is equal to 20 foot per second. And we have a coefficient of kinetic friction, mu k is equal to 0.5. And then we were asked the distance S. So let's apply the work and energy principle in this problem. Okay? So at first, we should draw an FBD of this object. So let's say we have an FBD here. So the motion is along that side. So let's say this is the X and the Y axis. We have the weight equals to 3,500 pounds. So the friction is always opposite to the motion. So yung motion is downwards. So ang friction is upwards. That is 10 degrees. And let's say denote the friction as small letter f. And then the normal force. We also have the normal force, NC, is 10 degrees from y. So, para mas dali ato ang buhaton ani is, since na relationship si N ug si normal force ug si friction, then we should solve first the normal force so we can get the friction which acts upon the of this object. So para mas dali na to siya ma-solve, let's rotate this FBD 10 degrees clockwise. So our new FBD here, so we will have the friction on this side, and then we will have a normal force here, and then a weight of the car 3,500 pounds there. So since girotate na to check 10 degrees, therefore this is 10 degrees. Okay, let's say this is our tangent axis, and then this is our normal axis. So next, on say bato na to, then we can simply solve for the normal force. It's much easier. So summation of the forces along the normal axis is equal to 0. Then we will have the normal force, NC, minus 3,500 cosine 10 degrees is equal to 0. Then NC is equal to, we have a 3,500 cosine 10, 3,446.8271 pounds. So na relationship si friction, right? So si friction is equal to mu k times the normal force, that is equal to 0.5 times the normal force nga 3,446.8271 pounds. Then ang ato ang frictional force, so we have a 0.5 times 3,446.8271, that is equal to 1,723.4136 pounds. So this is our frictional force. So unsay gaak nga force sa ato ang body, unsay ga-contribute sa work. So for this sample, so you have a motion along this side. So from this sample, ang forces that creates the work on this body is the frictional force and then the weight of the car. Okay, so unsa may atong buhaton ani in this case, so we'll have a again ato tong idumduman no ato ang work energy principle. We have the initial kinetic energy plus the summation of all the work done on the particle is equal to the final kinetic energy. So pwede nato na siya tagsa-tagsaon. Our initial kinetic energy is just equal to 1/2 mass times the initial velocity squared. So ato na i-substitute here. We have ang mass nato is 3,500 pounds divided by the gravitational acceleration sa imperial units, so that's 32.2 foot per second squared times initial velocity nato is 20 foot per second then squared. Then ang ato initial kinetic energy is ato is solve. We have 1/2 times 3,500 over 32.2 times 20 squared. So our initial kinetic energy is 21,739.1304 and ang unit is foot pound. Next unsay buhaton nato, we solve for the total work nga gaak sa body. So ang total work let's say ang work due to the friction is equal to the force, again force times distance, so that is force times atong distance na itong s, no? So that is just equal to 1,723.4136 s. So sa unit ani, is this a positive work or a negative work? Again, ang motion is on that side and then the friction is always opposite to the motion, so this is a negative work. So we also have a work due to the weight, so that is just equal to the weight times the displacement. Let's say the delta S. Again, since so looking from this sample, no, this is the direction of the motion. Sa ato pong kaon nga component ni weight is katong paingon po dato nga side. So that is the weight, which is equal to 3,500, and then iyang the component dato nga side, that is times cosine of the this is the sine of 10 degrees times ang displacement s. So we at along s atong gigamit, then we will have a 3,500 sine 10. We will have a 607.6766 s. So this is a positive work because ang direction sa o sa tangential component the weight is on that side and then ang motion is along that side pod. So ang total work done is just equal to ato lang ning isam. We have the negative 1,723.4136 s plus 607.7686 s. So that is just equal to negative 1,723.4136 plus 607.7686 is equal to negative 1,115.645. Then, what else? Our final kinetic energy, T2, is just equal to 1/2 m, then the final velocity. So we don't know the final velocity, but we know that the mass is just equal to 3,500 pounds over 32.2, and then V sub 2 squared. So our final kinetic energy, we have a value of 1/2 that's 3,500 divided by 32.2. So this is equal to 54.34782609 final square of the final velocity. So ato siyang i-rewrite in this form. So we have a T1 that is equal to 21,739.1304 foot pound. So ang final velocity nato is muhunong naman siya, so that is 0. So our final kinetic energy is just 0. And then minus 1,115.645 0.64. So this is S. 645S is equal to 0. Kaya itong final kinetic energy is 0. Kaya nihunong naman siya. So, simplifying 1115.645S is equal to 21,739.1304. So, we can solve for the S, which is equal to 21,739.1304 divided by 1,115.645, which is equal to 19.486 foot. Okay. So, ang iyang distance traveled from this point, sugod siyang pag-break until nihunong siya is equal to 19.486. So, you can see here that we can also use the work and energy principle to serve distances and then to solve also initial and final velocity of an object. So, atong gibuhat is, gibuhatan nato siya first with FBD, and then girotate nato siya para mas dali ang atong pag-solve or pag-analyze sa FBD. And then we take the forces nga possible nato nga makuha, such as the normal force and frictional force. Kay ang friction is mo act man siya sa kuan pod work. And then we write the work energy principle, which is the initial kinetic energy plus the total work done on an object is equal to the final kinetic energy. So ato siyang gita sa tagsa para mas dali, and this is the initial kinetic energy. And then we solve for the work due to the friction, and then the work due to the weight of the car, and then atong gikuha ilang total. And then we also solve for that final kinetic energy, which is equal to 0 because nihunong naman ang car. So 0 ang velocity. And then finally, we solve for S, which is equal to 19.486 foot or 19.5 foot. So this is the solution.